Hello, everyone. Today we want to practice a new platform called ComBase. What is ComBase? So we use ComBase for environmental risk of floodwater contamination. They use ComBase for predictions of microbial growth and activations, but mainly they have been using in food. But recently they have extended this application also in the water and soil. So what is the ComBase? So ComBase is actually, if you go to the ComBase and Google it, you will see the source comes from USDA. It's established in late 1990s through collaboration with U.S. Institute of Food Research and USDA and US. So if you go to the USDA, you can find this platform. And later I'll tell you when you want to download it, you can just Google it. You have to verify your email, then they will give you a code. You can then after that you can use this platform. It is originally designed to predict microbial community growth and modeling the different mathematical model and feed for survival and activation in food. And so it will predict a behavior variety of microbes, including E. coli and Salmonella under different storage conditions. However, uh, it has been extended to environmental application and environmental microbiology. They are using it for water and soil and flood environments. So DMFIT stands for dynamic modeling fit and predicting tools that will simulate the microbial responses under different scenarios. So what is the scenario? Scenario, as we talk people, it can be defined under different temperature, pH, and salinity. So when we talk about salinity here, in this case, we also talk about water activity. So because salinity and water activity, they have a reverse relationship. They're making this one adaptable to post disaster contamination studies that we will do one case study here today. As I talk about the sodium fluoride or salinity has reverse relationship with water activity. So water activity, we are showing with AW, so WA, so we are showing here with AW. I'm not sure why they are showing in AW. But anyway, the water activity measures how much free available water exists in the system of microbial use. So in the picture here, I think it's one of the recent papers. You can see the dissociations of the ions happens in NaCl, and each ion is surrounded by different water molecules. So adding NaCl, any solutes. So if you search it, you will see a lot of different solutes. So that's actually the reason we have hydrodynamic size when we are measuring the size of the nanoparticle, because the water molecules will be surrounding the nanoparticle. That's why the hydrodynamic size is much, much bigger and larger than the actual size. Adding sodium chloride or any solute ties up to the water molecule to the osmotic effect, and the ions attract and hold water, reducing the fraction available for microbes. So you can see as NaCl will increase, the water activity will go down. The microbial activity also will be impacted when it will be reduced. So we know that they use salt traditionally or in ancient time for killing the microbes because they have reverse relationship with microbial growth. That's why we have also a problem in soil when we are growing the plants. When we have salinity, it will impact the microbial community in rhizosphere. That's why they are not growing properly. And you can see here, for example, when we have no salinity, we have a pure water, it's approximately the water activity is about 1. But when we are increasing the salinity up to 3, the bacterial growth will be reduced. So at 0.5, we have a slight osmotic stress, 1.5% of sodium chloride, we have moderate stress, and at 3% we have growth boundary for many bacterial loads, so they cannot grow. That's why we have less microbial activities in saline and hypersaline waters. So responses, the microbial response to water activity or osmotic stress. When water activity decreases, microbial microbe experience, as you can see here, a slower metabolic activity that need to balance osmotic pressure, longer lag phase. So every microbe, they need a time to adapt to the condition. And so that time, we call it lag phase. So the longer lag phase, the time to adjust to internal salinity, that would be affected because not all the microbes survive in that range. Some microbes that they have more tolerance will survive. Lower maximum growth or growth rate, a slower cell division, uh, you will, you will face a slower cell, cell division, so the growth will be reduced as we have lower water activity and we have higher salinity. In extreme cases, no growth will happen. So in that case, we have higher salinity. If water activity below the organism minimum thresholds, that will have to happen, then no growth. So here we can see two examples of E. coli and Vibrio vermiculus, if I pronounce it properly, and their behavior in brackish water. So if we have a brackish water, we can have the data of the salinity and temperature and pH and important in this platform of ComBase. We're going to talk about ComBase soon, that how will impact it. Here you can see again another example of NaCl. The sodium and chloride ions have been surrounded by water molecule that will impact the microbial activity and growth rate. As NaCl also salinity will increase, the growth rate will be reduced. And salinity has also reverse relationship with water activity. In environmental microbiology, during a storm surges or seawater intrusion, salinity increases. So this reduces water activity. Therefore, we are limiting the survival of freshwater organisms, but favoring marine and halophilic bacteria. So those bacteria, they have high tolerance to to saline water, and they are halophilic, so they have more chance to grow. Now, the relationship between sodium chloride and water activity helps to explain which pathogen dominant after flood events. So when we have coastal flood, a lot of salt water enter to the environment. So it has pretty much making the brackish water because the salt water from ocean or sea will be mixed with the rainwater or flood. So we have a brackish water. Vibrio species proliferate in a warm, brackish, and low water activity environment. This is one of the predominant example where we can talk about it. You can see in the plot below is one of the recent papers that has been recently published, not really famous journals. But anyway, you can see the water and sodium chloride relationship with water activity. As the mole of sodium chloride will increase in the water acidity will be reduced. So today, in this lesson, we want to learn about ComBase and applying some different cases on ComBase and comparing different models. We navigate ComBase database and predictor tools. We analyze microbial survival data under environmental conditions. We apply predictive microbiology to real-world environmental risk cases and critically evaluate the limits of predictive models that we have in ComBase. The models are in ComBase. There are the fitting models, very limited. I believe there are 3 models, as I remember correctly. I used this model during my graduate studies in Texas A&M. We did a lot of different cases and scenarios for one of the courses. I felt like it is very important and it's a good opportunity for you to learn this platform. The basic three models that we have, one of them is a Baroni or a Roberts model that has a no lag. So this is best for microbial growth, sigmoidal curves. So we have different type of curves. This is a sigmoidal curve. It describes the lag phase, exponential, and a stationary phase smoothly. Uh, Most commonly used for food environmental data and used for E. coli floodwater growth data. Biphasic model has no lag phase for the best for inactivation survival with two phases. That's why they call it biphasic. It captures two distinct decay rates. For example, fast kill initial phase followed by a slower killing phase. It's excellent. It's a really good one for Salmonella survival database. Good part of the population resists to the stress. And we have also linear model. This is a simple first order decay. We talked about different order of decay, first order, second order. You remember we talked about it before. So this is a straight line declining of the log survival versus time. Then it has a constant death rate because it's a straight line, like a direct relationship. And this is direct relationship, it has no lag phase. It works well for the simple thermal or chemical inactivations, for example, chlorinated floodwater. So in VM feed, like dynamic modeling feed in ComBase, you can compare different plots. For example, you can compare botany for the growth, how quickly we proliferate once temperature rises. These are just example, and biphasic inactivation, how Salmonella shows initial decline, but part of the population persists, relevant to the post flood survival. In this case, we're going to talk about a new scenarios. And we will apply a new scenario. Flooding in Santa Cruz. So this is a wastewater flow in the river. So after you know, there's a flood, you have so much rain, and the wastewater will flow to the river. So the river has been used for irrigation and reception. There was a concern for E. coli contamination because there has been the overflow of the river. Your task is to use a ComBase to assess risk and recommend those strategies. So we will talk about the ComBase. First of all, you have to go to the ComBase.cc or just Google ComBase. The website will pop up. You have different type of microbes. You can see how the survival data applies. So you can manipulate different parameters and see how their growth will be affected and how the response of growth response or activation will be affected. Record the condition and the result and make a table. Then we will use a predictive model, use ComBase prediction with at least two different scenarios. You don't need to follow exactly this scenario. You can go your own scenario. 15 centigrade, pH 7, and water activity of 0.99, so water activity is the same. But we will see the impact of temperature, how the temperature increase will be impacted. We will compare the predictive growth cells. Then I will upload one assignment. You can do this assignment and you can have some discussion on how does the temperature affect E. coli survival, which scenario poses higher risk, and what monitoring strategies should the country adopt for monitoring, and what are the limitations of the ComBase predictive or prediction in the real floodwater. Compare prediction with EPA. This is optional. If you can do that, would be great. With EPA water quality standard, propose hazard mitigation strategies, closure of the surrounding areas, testing irrigation water, public health advisor. These are different things that you can compare and come up with different advisory levels. We talked about uh, different scenario in last session that I said we can make different scenario for the models. We can also add different advisory strategies in different scenarios, like high risk, low risk, moderate risk, based on what you think that would be uh, high risk or contamin or contamination of river or food or soil, things like that. Very easy. So we will look at the website. We will look at the ComBase platform and see how it will work. You can do this one uh, in a group, maybe two or three of you in one group. You can do it together. Uh, the table should be, you can give a report, 2 to 3 pages. Table should be completed and a screenshot of ComBase output. It's important and description of your answer.
To go to the ComBase, you can just go to the Google search ComBase. So this, you can see the link is associated to USDA, right? You can just click on the ComBase. I've already made my own accounts. Right, you need to register. What you need for registration, you just give them basic information, affiliation, and say that you are from Utah, University of Texas, and you can just log. But I already made it my registration, so I can just go to my account. Right. You can see it's a very, very simple. You can see the organism here in the search. We have food category, food name, condition, province, temperature, pH. You can search different things. So different type of microbes. I will give you assignment. You can search the type of microbes and you can see their conditions, all information about all type of microbes. For example, the best water activity, pH, the growth temperature, limitation, you can see all the information about different microbes. But they have also broth models. Here you can see the growth. The initial level is like the initial inoculation level, how much concentration you are adding to the growth. For example, if it's high concentrations or low concentrations, so if there's a high concentration, the like should be less compared to the low concentration, right? Then the physical states is a physical states like a water to solid basis. However, I'm not sure how they develop this physical states. I believe that highest concentration. Maybe how dense. You can figure out what's the temperature. You can manipulate temperature. You can manipulate pH. Here's water activity. You can click on salinity. And what the different salinity is about 5%. Here in this menu, you can choose different bacteria. For example, salmonella equals different bacteria. For example, salmonella equal Yersinia. Any microbe you can work with. There's a food model here. We are not working with food model. We can work with also dynamic modeling fit or DM fit. We have online DM fit. I will give you data. You can play. You can plug your data. You can just copy paste from Excel. Let me see if I find my Excel. So here, for example, my data, I copy and paste it here. It will paste it here. Then I press fit. So it will fit the data. This is a log CFU, colony farming unit. We talked about it. We talk about three different models, right? We have biphasic and we have linear model, right? Straight lines. You can also export or fit different with different models. And here is showing you data point. So you can play with this one and apply different data and see what fit is the best for your own data. And here you can also find out about your microbial community, what would be the best for your organisms. So it's very, very basic platform to use. You can explore more and see what other feature it is offering that we don't know about. For the next session for Wednesday, you can work on this ComBase and apply the data that I was post on Blackboard and submit your answers as assigned that I will assign.